So figure 2.5 show a cliff 5 meter above the beach. A boy that stands at the edge of the cliff thrown a stone horizontally with a speed of 18 meter per second. So we need to calculate the time interval after the stone being thrown until it strikes the beach. Okay, so we want to find for the time. And then we can see obviously the stone is doing projectile motion, whereby it's going to move downward 50 meter and then moving horizontally as well. So to solve this question, we need to separate all of our component into x motion and also y motion. So for the x motion, horizontally, there will be no acceleration because there will be no force acting along the x-axis. For y motion, we are going to have acceleration which is negative 9.81 meter per second squared due to the gravitational pull. Okay, sepanjang paksi y secara vertikal kita rasa tarikan gravity, so stone ni akan mengalami acceleration negative 9.81. Then we can break down the initial velocity into component x and y, but you can see obviously the stone very first is thrown horizontally, so the 18 meter per second is lie along the horizontal x-axis, so the component y for the initial velocity will be 0. 18 meter per second will be the component x. So we have ux is 18, our uy is 0. Then you can see obviously the stone is going to drop moving downwards 50 meter and then is moving forward x before it's landing on the beach. So we are going to have our horizontal displacement is x. Our vertical displacement will be negative 50. Why negative? Because the stone is moving downwards. Okay, then what is the speed when the stone landing on the beach? That one is also unknown. So we have Vx is unknown, Vy also unknown. So in order to obtain the time interval after the stone being thrown until it strikes the beach, so refer to the kinematic equations. So we can checking maybe for the y directions. So we know about the accelerations, we know about the initial velocity, we know about the displacement, so we can calculate the time taken. So I'm going to use equations 2. So for the y motions, consider the y motion. Sy will be uyt plus half ayt squared. So our sy is negative 50, our uy is 0, ay is negative 9.81. So we can calculate the time. It will be 3.19 seconds. Then we move on to the second question. We want to find the speed and the direction of the stone as it strikes the beach. So as the stone strikes at the beach, we are going to have certain value of velocity at a particular angle. Anyhow, we know that this particular final velocity must consist of component x and also component y. So in order to calculate the speed and the direction of the stone when it strikes the beach, we need to calculate the final velocity for the x and also the y component. So we consider the x motion using kinematic equations. V equal to u plus at. We do it for x motions. So for the x motion, we doesn't have accelerations. So our Vx will equal to Ux, which is 18 meter per second. Then for the y motions, then we do it for y motions. For the y motion, we are going to use kinematic equation. V is u plus at, but we consider the y motion whereby uy is 0 and our ay, the acceleration along the y axis, will be negative 9.81. The time taken for the motion is already calculated from question A, 3.19. So solve it, we will get the final velocity along the y directions will be negative 31.29 meter per second. So we already obtained the horizontal component and also the vertical component for the final velocity when the stone strike on the beach. So we can calculate the magnitude of the velocity. So the magnitude of the velocity can be combined, is the combination of component x and component y, and it can be obtained using the theorem Pythagoras. So we have the component x squared plus the component y squared square root. So we will get the magnitude of the velocity as the stone strike on the beach will be 36.1 meter per second. Then how about the directions? So the direction we can measure from the horizontal line. So the direction will be the opposite. For tangent theta, it will be the opposite divided by adjacent. So it will be negative 31.29 divided by 18. So I'm going to have negative 60.1 degree. So the negative telling you that the stone is heading downwards as it strikes on the beach. Okay. Then question C. Question C, we need to calculate the horizontal distance. Okay, the horizontal distance traveled by the stone before it strikes on the beach. So that one is represented by Sx or x. So the horizontal distance, we consider the x motion. So we use the kinematic equations again. S is ut plus half at squared. Then we understood that there will be no accelerations along the x-axis. So Ux is 18. The time taken for the stone to do projectile motions is 3.19. So we get the horizontal distance traveled by the stone before it's landing on the beach will be 57.42 meters.